Hello students, we were discussing chapter 3, motion in one dimension. Yesterday we have discussed displacement and distance. Okay, and also we have discussed what is average speed and average velocity. Okay, I am just repeating. Okay, with one example. Okay, so one example we take what is average velocity and average speed. To calculate average speed and average velocity, we take one example here. Here is a point O, okay, and here is a point Q, and here is a point P. Okay, suppose this O is 0 meter, okay, etc. etc. It is suppose it is showing 160 meter, okay, and this P is showing this point P is 280 meter. We assume this is 280 meter. Okay, just we are assuming here a body is traveling O to P. Body is traveling O to P. Okay, assume O to P time. What is the time taken for O to P? The time taken for O to P is we assume suppose it takes 10 seconds, and P to Q. P to Q time is equal to 6 seconds. Suppose it takes 6 seconds. So therefore distance is equal to, what is the distance? Distance is OP plus PQ. So OP distance is 160, PQ distance is 120. Okay, see, this distance is 280 minus 160, it is 120 meter. Okay, this one is 160, this is 280, so difference is 120. So therefore it is 280 meter. Okay, so 160 plus this it is traveling up to here. Okay, no, sorry, OP distance is here 280 here. Sorry, I have written here wrong. It is 280. O to P distance is 280 meter. So 280 plus 120, it is a total 400 meter. Okay, so 400 meter here. So this is the distance. See, I am calculating a body is traveling O to P and then P to Q. Okay, so it is coming and stopping here. So distance is OP plus PQ. Now what is displacement? See, displacement is, okay, it is final position minus initial position. Okay, so what is the final position and what is the initial position? See here, final position is Q, initial position is O, 0. Okay, starts from O, go to P and comes to Q. So it starts initially from O and its journey stops at Q. So what is the difference in these two positions? Difference is 160 minus 0, it is 160 meter. So this is a displacement. Therefore, average speed. Average speed is equal to distance upon time. Okay, distance we have calculated, it is 400 upon time taken is 10 plus 6, 400 upon 16. So meter per second. So whatever amount comes that we have written here, that is 25 meter per second. Next, average velocity. What is the average velocity? Average velocity is equal to displacement upon time. Displacement is, we have calculated here, displacement is 160. 160 upon total time is 16. So it is 10 meter per second. So one point is clear. See, magnitude of speed and velocity is not always equal. That point you have to remember here. Okay, the speed is greater than velocity in this case. Okay, this happens when path length is more. See, in this case, speed is more than velocity. This is because here path length is more. That is the reason here. Okay, we take one more example here. See, a body is traveling. Okay, suppose here a body is traveling a distance. Okay, if object is traveling distance here, see, this distance is d1 and this distance is d2. Okay, for this speed is v1, for this speed is v2, and again another distance is d3, speed is v3. What is the average speed? Average speed is question mark. What is the average speed? Average speed is equal to total distance upon total time. Okay, we have to take total time. Okay, so total distance d1 plus d2 plus d3, this is the total distance. What is the time for this t1, for this t2, for this t3? This equal to d1 plus d2 plus d3 upon t1, distance upon speed, distance upon speed, distance upon speed. See, so average speed is this. Average speed is also written like this. V bar is equal to like this. Okay, so average speed we have written this way. Okay, now if okay, we are having like this here. Okay, both are equal. Distance is d. This distance is d, and the whatever speed they have traveled is suppose for this it is v1, for this is v2. Okay, here d1 equal to d2 equal to d. Okay, if like this here, then what is the average speed? Okay, average speed is equal, this is symbol is what? Average speed. Average speed is equal to, okay, total distance upon total time. Total distance, it is d plus d upon time. What is the time for this one? Here time for this is distance upon speed. Time for this one is distance upon speed. Okay, this is t1 and this is t2. So t1 plus t2. See, distance is 2d, and t1 we have written here. T1 we already found here. Okay, this t1 is d by v1. This is d by v2. So v bar equal to, take v bar is equal to, take LCM here. Then it is 2d. Here d is common. 1 by v1 plus 1 by v2. d gets cancelled. Here v1 you take LCM, it will go to numerator. v1 v2, already 2 is there, 2. This is v1 plus v2. So v bar equal to 2v1 v2 by v1 plus v2. This is a formula. You have to remember this one. Okay, so we can say that if a car travels two equal distances with different speeds, car is traveling two equal distances with different speeds, then its average speed is 2v1 v2 by v1 plus v2. Okay, so this is the formula you have to remember. This formula you should not forget. Okay, we have to use it in the MCQs also. Okay, we use it in the MCQs also, this formula. That is fine. Okay, next one. See, we have a position time graph. Okay, see, position time graph. We have different position time graphs are there here. Okay, so first we take this graph here. It is like this. This is x-axis, and this is, sorry, this is y-axis, and this is x-axis. We take a position on x-axis, and time we take on position we are taking on y-axis, time we are taking on x-axis here. See, like this here. First case, okay, we assume that suppose this is a graph. Okay, here time is, suppose it is 1 hour, 2 hours, 3 hours, 4 hours. Assume, okay, it is an hours. Okay, see, time is changing. 1 hour, your position is here. After 2 hours, position is here. 3 hours, 4 hours, position is not changing. Your position is, suppose from here to here, this is 4 kilometers. Okay, so your position is after 1 hour 4 kilometers, after 2 hours 4 kilometers, after 3 hours also 4 kilometers. Okay, so we say body is at rest, because there is no change in position. No change in position. If your body is not changing its position, okay, means body is at rest. So we remember this one. Okay, for a position time graph, okay, it is at parallel to the time axis. Body is at rest. So you have to remember this one. Okay. When body is at rest, velocity is equal to 0. Next, second case. Okay, see, position time graph we are taking like this, x, and this one is time. Okay, graph is a straight line. So we say it is a uniform motion. Okay, this one is uniform motion, or you can say uniform velocity. Okay, you can say it is a uniform motion or velocity. Why? Because at regular intervals, okay, position is changing here. At regular intervals, its position is changing here. So therefore, body has a uniform velocity or uniform motion. Remember this. What is uniform motion? We will define now. Okay. Third case here. Okay, body is having like this here. Okay, means position time graph is not constant. It is a variable. So it is a variable motion. Why it is variable motion? Position is changing. Okay, position is changing irregularly. Irregularly it is changing here. Okay, so therefore it is a variable motion. Okay, so these are position time graphs we are having here. Next, what is uniform motion? Okay, uniform motion. I just said we'll discuss. Uniform motion means see equal changes in position in equal intervals of time. Equal changes in position. Okay, in equal intervals of time. Okay, then we call this is equal intervals of time. We call it is uniform motion. Okay, equal intervals of time is known as a uniform motion. Okay, see this is uniform motion. Okay, 1 second, 2 second, 3 second. Here it is 1 meter, 2 meter. This is 3 meter. After 1 second, it is 1 meter distance. After 2 second, 2 meter distance. After 3 second, 3 meter distance. Means every 1 second displacement is here 1 meter. That is why it is having a uniform motion. Okay, so this is about position time graph here. Okay, next we have instantaneous velocity. What is instantaneous velocity? Instantaneous velocity. See, instantaneous velocity means velocity at any instant of time. Okay, at any instant you look at the watch and see it. Okay, at any instant of time. Okay, see we have in car speedometer is there. Okay, in car speedometer. Okay, car speedometer gives instantaneous velocity. Okay, whenever you look at the speedometer, the speed whatever it shows, it is the speed of the car at that instant. That is why it gives instantaneous velocity. Okay, suppose we assume that okay, a body, one object is there here. Okay, it covers a distance, okay, delta x, okay, in time delta t. Delta t time it has covered a certain distance here. Okay, so or you can say it is a displacement. Displacement is delta x in time delta t here. Then average velocity. What is the average velocity? Average velocity is equal to total displacement upon total time. See, total displacement is delta x and total time is t. Okay, we are writing v is equal to delta x upon delta t. This is the average velocity. But we want instantaneous. We are talking about instantaneous velocity. Okay, so to get instantaneous velocity, we want instantaneous velocity. Okay, what we do? We take a limit here. Okay, we take a limit delta t tends to 0. Okay, means we write like this here. Okay, we write a limit delta t tends to 0. Like this we write here. Okay, so to get instantaneous velocity, where average instantaneous velocity is equal to insta velocity is equal to, that is v is equal to limit delta t tends to 0 delta x upon delta t. Okay, v is equal to this equal to dx upon dt. Okay, this is a formula. So here limit delta t tends to 0. What is the limit delta t tends to 0? It is not we are making time 0. Okay, we are taking time small. So we are taking a time is made small and small. You make a time small and small, you will get a velocity at a particular instant. That is why we are writing limit delta t tends to 0. This is okay, mathematically. Okay, this expression is written like this here. Mathematically, this is written like this here. What is dx by dt? Dx by dt is called differentiation. Remember, okay, it is called differentiation. Differentiation means what's the meaning of differentiation? Differentiation means rate of change of, that is the meaning. Okay, see here dx by dt is there. So what is this differentiation? Differentiation means d by dx is and dx by dt is there. It is called differentiation. Okay, so we write this is see differentiation of differentiation of x with respect to time. Differentiation of with respect to time, okay, is velocity. Okay, what is x here? See, remember, x is position. Okay, x is here, position here. See, again I'm writing what is the meaning of this one. Differentiation of x with respect to time means see rate of change of, okay, change of x with respect to time. Rate of change of x. What's the meaning of this differentiation? Differentiation means rate of change of, that is the meaning. Differentiation means rate of change of, okay, x with respect to time. Okay, means rate of change of position. What is this rate of change of position? Rate of change of position means this is nothing but displacement. Position is changing. Position is changing means displacement is there. Okay, so displacement with respect to time is called velocity. Okay, so displacement with respect to time. So what we are considering is here. So therefore finally v is equal to dx by dt. Okay, what is this meaning here? The rate of change of position. See, it is rate of change of position, okay, is called velocity. What is this one? Here velocity is dx by dt. What's the meaning of this one? Rate of change of position, or we can also write, okay, the rate of change of position, or we can say displacement. Change in position is nothing but here displacement. Rate of change, here rate means with respect to time here. Okay, now, so rate of change of position is called velocity. Okay, it is in if it is x direction, we write dx. Okay, for y direction, if it is y direction, we write dy by dt. Okay, or in 3D, in 3 dimensions, we write v is equal to dr by dt. Okay, this is dr by dt. Okay, see here v is equal to dx by dt. What is the meaning of dx by dt? Dx by dt means rate of change of position. Differentiation means rate of change of x is a position. Okay, so rate of change of position with respect to time is called velocity. If this is in x direction, we write dx by dt. For y direction, dy by dt. Okay, for 3 dimensions means in space. 3 dimension means in space. Okay, v is equal to dr by dt. Velocity is a vector quantity. That's why we write vector v. Okay, that of course we see when vectors we study. That time we can study there. Okay, so we have to remember this formula. Rate of change of position. The rate of change of position is called velocity. That point we have to remember here. Okay, now we have one note. We have to remember this point here. What is this one here? See, I am having one graph here like this here. This graph is drawn between position and time. Okay, this x is what here? Position. Graph is drawn between position and time. See, at this point, okay, time is here t1. What is the position here? It is x1. Now we take another point here. So position at this point is x2. Here what is the time here? t2. Okay, so this point is supposed to a and this point is here b. Now I want to, okay, see at a, this body has velocity. Okay, how much velocity? See, v1 velocity, that is given by x1 by t1. Okay, body has velocity v1 and v2 at b. So v2 is equal to x2 by t2. See, at a what is the velocity? Velocity is v1. At b what is the velocity? v2. Okay, so when then average velocity is equal to, how to get average velocity? So to get this average velocity means v bar What is the formula? It is total displacement upon total time. We have to get total displacement. What is the total displacement? Delta x. Okay, this difference is your delta x, and total time is delta t. This difference is delta t. So we have taken this much here. So this delta x by delta t. Okay, if you draw one line here, see, like this here. Okay, see, this is slope. Delta x by delta t is what here? Slope of line or chord. We say it is a chord. Chord AB. This is a chord because it is a curve here. This line we call chord. Slope of the chord gives this one here. Okay, so you have to remember, see, if velocity is variable and the graph is a curve, okay, so for variable velocity, graph is a curve. For variable velocity, graph is a curve. Then we have to remember slope of the chord AB gives average velocity. You have to remember this part. So what I am saying is this one here. For variable velocity, graph is a curve. See, it is like a curve here. So the average velocity is given by slope of the chord. Okay. So you have to remember this one. Okay. Whenever they have given curve is given. Okay. What's the average velocity? So slope of the chord gives average velocity. That you have to remember. Okay. Next, in this second point, note first point is this. Okay. Note second point is like this here. See, we are having this is again same graph I am casting. Okay, like this here. This is the position and this one is here time. Okay, this point is A and this point is B. That is what we have taken. Now, I want instantaneous velocity. Okay, so to get instantaneous velocity, what we do? Take a point P here. Okay, this is a point P. At this point P, draw one tangent. Draw a tangent. Okay, see, instantaneous velocity at P is obtained. How to get this instantaneous velocity at P is obtained by drawing one tangent. You draw one tangent. Is it possible to draw? Okay, just take one point here and draw one line here. Okay, so slope of this tangent gives, okay, find the slope, okay, gives instantaneous velocity. Remember, so you have to remember this one. Instantaneous velocity is equal to slope of tangent. You have to remember this point here. Slope of the tangent drawn at any point, at that point. You have to remember this point here. Okay, these points are important for okay knowledge. Okay, if curve is there, so for this using the slope of the chord gives the average velocity and slope of the tangent gives the instantaneous velocity. This is what you have to remember for this one here. Okay, so when velocity is variable, remember when velocity is variable, the graph is a curve like this here. Graph is a curve. When graph is a curve, remember average velocity is obtained by finding the slope of the chord and instantaneous velocity is obtained by finding the in velocity of slope of the tangent. Okay, so you have to remember these 2 points here. Okay, this is only for knowledge purpose, for your knowledge purpose. Now we have next acceleration. See, what is acceleration? See, acceleration is the time rate of change of velocity. Okay, time rate of change of velocity is called time rate of change of velocity. Okay, see,